Number 10 on 8.1.
Thank you.
You're welcome. So we can set this up as y minus 1 over 16 is equal to y over 18. Now this one here, we do have two variables. So to get rid of the fractions, we will multiply both sides by 18 because these will cancel. So what we'll also have to multiply both sides by is by 16 to get these two sides to cancel. So we have to multiply by both 16 and 18. So for this one here, we had to multiply by more than one number. We had to multiply both sides by 16 and 18. Now with 18, if we distribute it, 18 times y is 18y. 18 times negative 1 is negative 18. 16 times y is 16y. Now at this point here, we do need to get y by itself. So we can subtract 18y from both sides, telling us that negative 18 is equal to negative 2y. And then last but not least, we can divide both sides by negative 2, telling us y is 9. So y would be 9, and this here would be 8. But I think they were just asking for the value of y. You're welcome. Yeah. Are there any questions on any of the assignments? Okay. So the first thing we did was multiply by 16 and 18 to get the denominators to cancel. Because here the 18 and 18 would cancel, leaving us with 16y. Here the 16 and 16 cancels, leaving us 18 times y minus 1. We wanted to get the fractions to simplify out. Essentially what we're doing is also called the butterfly cross multiply, is essentially what we did here, but it's just in another form. Then we're just getting y by itself from the rest of these steps. Questions on this here? What we're looking at today is the side-side-side similarity theorem. Now, side-side-side is similar to the side-side-side congruency theorem, but instead of the sides being congruent, they're going to be similar. The proportions have to be the same. So the proportions of the sides, the scale has to be the same for all three sets. If it is, then the sides are proportional. If it's not, then they are not. Now, here we're trying to determine if DEF or GHJ is similar to ABC. So part of our similarity statement is going to be triangle ABC is similar to another triangle. So we're comparing these all back to ABC. We're comparing it all to this triangle here. Now this problem here was, nice in that it color coded the sides. 8 is red, 12 is green, and 16 is blue. But when we can match these up, the biggest side is going to go with the biggest side. Smallest side with smallest, and middle with middle. Now we can start off with the blue, 16, over, well, Do we want to check DEF or JHG first? DEF. So we could say 16 over 12. Then we also have 12 over 9. And lastly, we have 8 over 6. And when we set the proportions up, I just picked one of the side lengths. I picked 16 because it's the biggest. So I put that side, biggest side, over the biggest side of DEF. And since I put ABC 16 first, its side length of 12 goes on top. 8 goes on top. Whichever side length of the triangle we put on top, those all sides go on top, and then the others go on bottom. Now at this point here, we just need to reduce these, 16 over 12. Well, we could do that in a calculator. 16 over 12 is 4/3. Or 1 1/3, either work. Now we can look at 12/9 is and lastly 8/6 is we have 3 sets of proportional sides, yes? So ABC would be the same as by side, side, side. Now we can look at ABC and GHJ because we would have 12 over, well, let's do 16 over 16. Biggest sides are 16. Thank you. Then our middle side is 12, and the middle side of the other triangle is 10. And lastly, we have 8 and 8. Well, what is 16 over 16 reduced to? 8 over 8 is 12 over 10 is not 1. Since they are not all the same proportion, they're not similar. So ABC and DEF are similar. Because as soon as we get one proportion that's not the same as the others, we can say that they are not similar. Okay. PQR or SDQ is similar to triangle VWX. So we're comparing it to VWX. Which one do we want to try first? 20, 20, 30 or 12, 12, 16? 20, 20, 30. So we could start off with the bigger side. So 12 over, not 20, 30. Because we got 12 over 30. Because 12 is the biggest side for this triangle here. 30 is the biggest side for this one here. Then we'd have 8 over 20 and 8 over 20. So 12 over 30 is 2/5. 8 over 20 is so it would be by side, side, side. Is there any chance that S or PQR is going to be similar? So we can check and see. Well, we have multiple, 16 over 12. And we could have 12 over 8 and 12 over 8. So this time here, 16 over 12, I did it flipped because it doesn't matter which one we put on top. We just need to keep them be the same. 16 over 12. 16 over 12 is 4/3. 12 over 8 is so are all three of these the same? No. So the proportions are not the same. Four over 3. Because this would not need to be 8. These would both need to be 9, I believe. 12 ninths is 4/3. So if the other two sides had been 9 for VXW, it would have worked. Or 12 and 12 with 8, 3 over 4. Yeah, it would have had to change one of them to get them to be the same. All right, which of these triangles are similar? So do we know which one is going to be similar to the other two? Nope. So we just need to pick two and go from there. So which ones do we want to try first? RST and L&M. Okay. 33 over 26, because 33 is the biggest for RST, 26 is the biggest for LMN. What's our next ones? 24 for RST and 24 over 24, yes? And the last one, if we set it up, would be, well, actually, no, this is a little off. Yes. Because the middle side for this is 30, and then the last one would be 24 over 20. Doesn't mean it still won't be no, but we can just go on and check it. Yes. Because the other option that we would have for this would be 26 over 33. Because bigger over bigger. Then we would have 24 the middle over 30. And lastly, 20 over 24. So if we do 33 over 26 over 26 reduces 2. Or if we did 26 over 33, we get the same. It's just flipped. So this is just 33 over 26 or 26 over 33. 30 over 24 is, yeah, we already have one different. And 20 over 24, if we wanted to look at it, 20 over 24, 5/6, or 6/5, yeah. I had it flipped. But yeah, we can actually get 3 different proportions. So these two are not similar. Okay, which two do we want to try next? So RST and, yeah, we can do those two. And if those two don't work, well, we know it has to be LMN and XYZ. Now with these two here, the biggest side, for which one do we want to start with? So 33, 39, or 39 over 33, either way. Since I put 33 on top, since 33 I put it on top, it's biggest. The next one we can say is 30 over 36. And lastly, 24 over 30, yes? 33 over 39. 33 over 39 is 11/13. It's not looking good. 30 over 36 is, and 24 over 30 4/5. Those aren't similar. So that leaves us with LMN and XYZ. So we can check it to make sure. So I could say 39 over 26. That's going on 39 over 26 is 3/2. Then we have 36 over 36 over 24 is, surprisingly or not, is 3/2. And lastly, 30 over is 3/2 because, well, so we say triangle what? So LMN, we started at L, short, middle, biggest. Yes? So we need to finish with the biggest one. So shortest is writing the similarity statement. Now what we could have done is matched up the corresponding or similar sides. So it said 1, 2, 3. So I gave the smallest side 1, middle side 2, biggest side 3. We went 1, 2, 3. So 1, 2, 1, 2, 3, 1, 2, 3. Just get a way to match up the sides or angles. Or you could have done it with angles. Let's see here. Because we can match up the angles a little better. Because L, between the smallest and biggest, Y is smallest and biggest. M, smallest and middle, and then match the angles up. Yes. Yes, and there's so many different ways that we can do it. Also, any questions on this here? So we know the sides, these two triangles are similar. So we want to find the value of x. So this isn't really different than angle. We're just given proportions. Now, so A, B, C, A, D, E, F. Now I'm putting marks on the angle so I can get an idea of which sides match up with which sides. So 4 is going to match up with what? X minus 1 matches up with, and 8 matches up with 3 times x plus 1, yes? Now, we're going to have a proportion. We're going to have two fractions set equal to each other, yes? We need one of the variables. So we either need x minus 1 or 3 times x plus 1. And it's going to be over what? What can we put on top of the other one? 4. Why wouldn't I want to put 8? So what would be on bottom with 8? 3 times x plus 1. This would still work. We would still get the correct answer. It's more that we have to do because if I use 4, we can put it over 12. Now, yes, the cross multiply. I don't like the term cross multiply, but what we're going to do is multiply both sides by the bottoms of the fractions, the denominators. Now I'm going to write this first one out so that we see this here. Now I'm going to write it out for this one here so we can see it. Because if we multiply the left side by 12 and 18, we'd have 12 times 18 times x minus 1 over 18. Anything divided by itself is 1. So that leaves us with 12 times x minus 1. Over here we have 4 times 12 times 18 divided by 12. Well, the 12 and 12 will cancel, leaving us with 4 times 18. Questions on how we got to this point here? Now here we can distribute the 12. 12 times x is 12 times negative 1 is negative 12. 4 times 18. 72. And we would add 12, because negative 12 plus 12 is 0. Telling us that 12x is equal to 3. Yeah, so we'll look at that here in a second. I'll leave this here. Is everybody good with copying this down? Yes. So 7. Yeah, it's just asking us to find the value of x. So, exactly. So from here to here, we're multiplying it by 3, yes? But from here, so that means here to here, we're also multiplying it by, so 3 times x minus 1 is equal to 18, yes. We can divide by 3. X minus 1 is? Yeah.
That's how I would have to do it better. I'm sorry if I confused anybody. That just makes it a lot easier.
Not necessarily, no. Because 4 12s times 18 is 6. So we didn't necessarily have to multiply by 12. But we can if we want to. The only time we wouldn't is if that didn't reduce. But since we're talking about scalars, most likely it's going to. Yes, they will be proportional. Now let's look at this here. XYZ is similar to H. Okay, yep, nope, that's why. So XYZ HJK. So our 15 and 3, 30 and x minus 5, and 5 times x minus 6 and 5. So we could say x minus 5 over 30 is equal to what over what? 3 over 15. So what can we multiply both sides by first? We can do 30. And as we kind of said, it's off the video, but here, the 30 and 30 will cancel. We kind of covered that earlier. So we get x minus 5. Now, on the last one, we also multiplied both sides by 15. But let's see what 3 over 15 times 30 will give us. It gives us 6. Now, the reason we're multiplying both sides by 30 is to get the fractions to simplify, to go away. Now, just multiplying by 30, did all the fractions simplify? Yes. If they didn't, then I would need to multiply with the other denominator.
So as long as it's simplified.
Just multiply the 1. Then we would need to do what? So x is, and that's it. Questions on this here? Side angle side similarity theorem. SAS. If an angle of one triangle is congruent to an angle of a second triangle, and the side lengths on the sides, including these angles, are proportional, then the triangles are similar. So if we have a set of angles that are congruent, and the sides, this one here, over this one here, is proportional to this side over, these sides over the top of each other, then the two triangles are similar. So if we look at this here, so we know angle F are congruent. Now we need two sides that are proportional. So have the same proportion like we did with side, side, side. Or they reduce to the same fraction. We need that here. Now for this one triangle, we have 6 and 10. So we would have 6 and 9, 10 and. Now we just need to reduce 6 over 9 and 10 over 15 to see if they are the same. 6 over 9 is 2/3. 10 over 15 is 'So can we say these two triangles are similar? Yeah. So we're building a lean-to shelter starting from a tree branch as shown. Can you construct the right angle so it's similar to the left using the angles and lengths below? Yes. Because the two triangles are similar, so it works. Yeah. Yeah. Yep.
It's okay. Go ahead of it.
Because this would be 8, and then this would be 12. Pythagorean's theorem, 3, 4, 5 right triangles. 3 times 2 is, 4 times 2 is, 5 times 2 is 10. Well, 5 times 3 is 15. 3 times 3 is 9. So 4 times 3 is.
So with the similarities, we can basically just go through to
Well, this here actually worked out to be 3, 4, 5 right triangles.
Yeah.
So that's the only way I got to those. These here aren't 3, 4, 5s, but we want to see if they are similar. Now, angle R is congruent to angle N, yes? So this is our angle. Now we need to show our two sets of proportional sides. So So I need to pick one of the two sides on SRT. So 24 and 28. So 24 is the smaller of the two, so we would indeed pick 18. And then we would have, so 24 over 18. Exactly. Well, 4/3. And it works out 28 over 21 is. So, by SAS. I think we have one more here and we're done, yes? Or about. Okay, so looking at this here, XZW, let's try that again, XZW, this triangle is similar to YZX. Now these two angles here are both right angles. So for our angle, we can say angle XZW is congruent to angle XZY. Because there's more than one angle there, we have to have more than one letter. Now our sides. So we need two sides from XZW. So 20. Biggest side would be 15. What would be another one?
16 over
16 would be the middle. 9 would not be the middle.
9. Oh,
12. So 12 over 15 is 4/3. 16 over 12 is 4/3. So they are similar by side angle side. Staffs. Questions on any of this here? So the three theorems that we have for similarity are angle, angle, or angle, 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 three angles, side, 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 and side, angle, side. Your homework, page 397, problems 3 through 10.